thank you all for coming to this today. This is really an awesome day for us at the Texas Advanced Computing Center, and I appreciate all of the nice compliments that I've been given, but I want to point out that this has been a tremendous team effort. We've had an enormous amount of success over the past 6 years, and I'm happy to brag about that because they say, as they say in Texas, it ain't bragging if it's true, and we've really done a stupendous job, but we've done it as a team. And so I would like to point out that everybody you see that's wearing one of these little Ranger badges today is actually on the staff of the Texas Advanced Computing Center. It's several times larger staff than it was when I got here in 2001. There are over 70 people on the staff now. We are growing fast. We probably have to hire probably about 10 more by tomorrow, I think, based on the open positions we've got. So I really want to thank everybody on the team first before I even begin, and in particular acknowledge Dr. Carl Schultz and Dr. Tommy Minyard back here, hiding in the back, but absolutely on the forefront of the project. So now, what are the odds that this is going to work? Hey, how about that? So just a little bit about today. Some of you maybe have been to some dedication ceremonies that we've had before, and so you know this wasn't a one-time thing. We've really spent considerable effort over the past 6 years getting to this point. We've had a number of firsts in that time. We deployed the first power open architecture system in the United States from IBM across the street from TACC back in late 2002, the first one available to the open science community. We deployed the first large-scale Linux cluster available to the open science community as part of the TerraGrid. We've had a number of firsts in our own R&D efforts in-house. We've hired now 20 PhDs who are conducting innovative research and development activities in advanced computing technologies. We, of course, competed for and won the right to join the National Science Foundation TerraGrid a few years ago. So there have been a number of successes and developments enabled by this team, and it's really nice to see them all coalesce into what is easily the biggest and most important day in our history, which is the awareness of the recognition of the system today. I want to just say that I'm really grateful for working with this team, and we really do have now the expertise and experience that really the University of Texas deserves and the national science community needs. So we're really excited about this opportunity. I want to point out that this exists in a culture at the University of Texas that has undergone a dramatic change in the last 6.5 years. So I still remember about 7 years ago when Tinsley Oden convinced me to think about coming home. I did my graduate work here at the University of Texas, and I met with Juan. And by the way, that was not the charge Juan gave me when I got here. And I remember meeting with them and thinking, well, there's a lot of work to do, but it is the University of Texas at Austin. And it's in Austin, Texas, home to great technology companies and with great expertise in the community as well as the university. So it's certainly possible. So when I got here, the culture was not really one of scientific computing, although it was world-class in many other respects. Over that last 6 years, though, one of the things that's enabled us to succeed is the support and the culture change here at the University of Texas at Austin, the tremendous growth in places like the Institute for Computational Engineering and Sciences and the growth in computational programs and the Jackson School of Geosciences and the College of Natural Sciences and the Cockrell School of Engineering. And I'm really proud to say that we've been a big part of that. When I first got here, the amount of externally funded research that was conducted by principal investigators using TACC was about $15 million a year. Now it's about $200 million a year, so you can see the impact of TACC on external funding here has been tremendous in that time. So let's talk about, whoops, there's a little bit of latency here, Ranger, and I wanted to make sure that I showed you some of these big numbers here. It's a $59 million award from the National Science Foundation. As Juan said, it was in September 2006. We started planning for this at the end of 2005 and submitted the proposal in February of 2006. It's 504 teraflops of peak computational performance, half a petaflop, provided by these brand new AMD Barcelona, well, now called AMD quad-core processors. I'm quite sure we have more of these than anyone else in the world. We have nearly 16,000 of these processors and constant requests from people to access our system because they can't quite get one yet and they want to have access to one. And I said, well, we've got a few. It's also got over a petabyte of disk and over 120 terabytes of memory. These are equally important for making it a powerful supercomputer. This enables us to conduct the largest simulations, not just of any open science system in the world, but of any supercomputing system in the world. So by most metrics, I would call this, without a doubt, the most powerful and general purpose supercomputing system for research ever. As was mentioned before, it's got over 500 million processor hours per year of compute capability, which means over its computational lifetime, it'll do over 200,000 years of computational work. That is a tremendous capacity that has been enabled by the National Science Foundation program to give the nation's leading researchers the instrument they need to conduct leading-edge computational science. And it really is a national resource. It's funded by the National Science Foundation, and it will enable the national open science community to conduct the kinds of simulations that they've been dreaming about and putting into reports based on federally commissioned panels saying that we need these kinds of systems to do these kinds of problems, problems that span science and engineering disciplines and reach deeply into society as well. It's really going to enable a large number of applications. On this slide, I just have a few of the kinds of applications that are already running on Ranger. The demand for Ranger was so great that we tried to limit the early user program to about 6 to 10 people originally, 6 to 10 research teams, sorry, originally, to use the system. And that grew to 12, and it grew to 15, and it grew to 18, because we just couldn't say no to some of these really interesting projects that said they'd been waiting so long for a system like this. They promised to do whatever we asked them to do in order to get access to this system in December. So their Christmas present for those 18 research groups was they got access to the system in December. Now, we asked them, of course, not to treat it as a production resource at that time, but just to do some testing and give us feedback. And we noticed some of these research groups running code after code, application after application, not doing testing, doing production computational science research because they could not wait. So in fact, when we report our numbers for usage of the system, we probably should go back and look at some of the so-called test period numbers because so much science actually got done in that phase. Of course, the installation is complete. We went into full production on February 4th. It's really the time for impact now, though. So we're marking today as a celebration of deploying and installing the system. But the real celebration is going to be over the next 4 years, every time researchers are enabled to accomplish simulations they could not have otherwise conducted, leading to knowledge discovery. That's really why we're in this. We're enablers of scientists and engineers in all disciplines. We want to help them conduct world-class science that increases our understanding of the world and has a direct impact on it.